Thanks, Ben, for the introduction. Hey everyone. It's so great to see you all. This is my third year in the amazing Ad Filtering Dev Summit, and I cannot be super excited. This is great. So many interesting topics about AI, so I'm so excited to also mention that we are also talking about the impact of AI on ad filtering. So, we are in the journey of an era of transformative transformation, where AI is reshaping, if not all, most of the industries and most of the aspects of our life. So, let's reflect on the significance of AI. AI represents the ability of machines to mimic human intelligence, which enables the machines to think about making better decisions and so on, which makes it so much easier to solve the complex problems, automate tedious tasks, etc., right? And the topic of AI influencing on ad filtering becomes one of the crucial topics in today's digital landscape, because AI is not just impacting on the ad filtering side of things, but also on the ad tech. So influencing both the sides of the ad filtering equation. Let's quickly take a look at the status quo. Today, we have around 42.7% internet users who are using AI. Sorry, a lot of them are using AI, but 42.7% of internet users out there are using ad filtering solutions. And they are spread across different regions in the globe. And clearly, the APAC and North America are leading in this aspect. So we all very well are aware of some of the main motivations of using ad filtering. There's too many ads on the internet. And those are annoying, irrelevant, so many more. But where are we in terms of ad filtering today? We have so many advancements. We have acceptable ads. So the acceptable ads lets the user get the acceptable ads displayed, non-intrusive ads displayed, and this this approach enhances the healthy balance between the user experience and ad revenue for publishers. And then we have user privacy. The privacy concerns lately have enabled a lot of mobile and web browser vendors out there to come up with ad filtering solutions, which address not only ad filtering, but also block the trackers and third-party cookies. And we have these extended to mobile solutions, web browsers, etc. And then there's AI. Let's take a zoom in at the AI part. So how is AI changing the landscape? Like I mentioned earlier, AI is not just impacting the ad filtering side of things. It's impacting both the sides of this equation. Now, talking about the other side, the ad tech itself, there's a lot of advancements. And here I'm just pointing out a very, very few, if you will. Like, for example, advanced targeting, where the user's preferences, behaviors are studied and analyzed, and the ads that are relevant to the users are being served. And there's content generation, where generative AI and different other such latest techniques are creating different ad formats which are so advanced. And then there's programmatic advertising, ad placement optimization, voice-activated ads, and our great friends from AdGuard just explained the whole scenario with conversational AI in the morning. So yeah, it's great out there. We are getting new ad formats. We are able to notice very new ad formats coming onto the surface. Like, for example, the text ads, which are so seamlessly integrated as part of the responses generated by these AI chatbots that it makes it super challenging for the traditional ad filtering rules to work on it. And then there's display conversational ads, where you have display, a banner, and a chatbot integrated as part of it. And this chatbot generates the ads based on the context that user is providing. The same day that Snapchat's My AI wanted to have a partnership with Microsoft's APIs, the same day, Microsoft announced about their new first conversational ad experiences called the Compare and Decide ads. So these are the ads generated in the conversational experiences, and they are completely based on real-time context provided by the users. Now, that's just a few of the advancements happening on the ad tech side. Let's take a look at the other side of the spectrum. What about the ad filtering landscape? There's many aspects that the ad filtering solutions are also trying to focus on today, like improved ad detection, behavioral user-centric filtering, privacy enhancements, anti-circumvention, content generation, primarily the automation. What we at eyeo are doing. So we all know how traditional ad filtering works. There's a user, opens anything on the web based on the fact that he has ad filtering solution or not. The experience is different. Like if he has one, he has better user experience. If not, then the regular ad experience. But here's where we are bringing AI, and we are trying so many different techniques with AI. We are pretty much focusing on most of the aspects here listed down. Like for example, the improved ad detection, privacy and circumvention, and the automation mainly. Up to now, in our research and development area, we first started our journey with experimenting using computer vision, especially the method that we employed is perceptual ad detection. In the previous year, we have given a presentation on how we did all of this and what were the learnings. But yeah, this was our first step. And we decided that this is very computationally heavy, and there's a lot of latency associated, and we cannot afford to have such latencies. So sooner or later, we moved into experimenting with natural language processing. Though the progress is happening on this area, the most we have focused and succeeded on is in the area of deep learning. So we've experimented with different models. We've trained the graph neural networks to identify content as an organic versus ad, and we've had great results so far. And we have recently started exploring the area of generative AI. We are analyzing the potential possibility and opportunity of such conversational AI experiences and dynamic filter rules generation. So these are just a few of the initiatives that we have on our plate. But the most important thing for us in all of this is the journey itself. We have had so many challenges, so many successes, so many failures, so many learnings. I mean, it's been a roller coaster journey, really. Humera, what do you think? Humera, where are you? Did I lose you again? Hey.
I'm here. Coming. Hey, everyone. Hi, Pari.
Hey. So I was asking you, we've had a roller coaster journey. What do you think?
My journey was very good. I'm coming from Munich, and we were having Oktoberfest there. Why don't you have a seat?
No. I think I'll let you take them through the learnings and rest of the things. But I'll all see you guys soon.
All right, thank you. Then maybe you can take the chairs as well. Thank you. Hey, everyone. Thank you. So the scene in Munich actually looked like this while I was traveling. So it was so much of fun going on. But since I was about to talk about AI, so I thought, what does AI think about Oktoberfest? So I searched for some images, and this is what I got. Exactly. AI is a double-edged sword. We can't take it very easily. We have to be very careful when we talk about AI. On one side, we can have amazing tools like ChatGPT, which can be our companion and our supporter and our assistant. And on the other hand side, it can be an irritating and intrusive adbot. So at eyeo, we made sure that we use AI responsibly and ethically to do whatever we are doing. So Pari was saying about the journey that we had, and we definitely had a very, very nice journey, a lot of failures, but a lot of successes, where we are actually very proud of the achievements that we did. So let me take you through those achievements. That came in handy, actually. Now, I'll talk about two parts. My talk will be in two parts. One of them will be, as I said, about the learnings. And here I'll be very tactical about what I'm about to present. So I'll give you some tips, very practical tips that we had in order to build our machine learning solutions, so that in case you want to implement them, you have the exact pointers on how to implement them. And then I'll go through a very concrete example of implementation of ethical AI, which is sustainability. So let's get started with lessons from the front lines. And I'll talk about four dimensions. One of them is size. The other is performance, where I'll talk about speed. Then our challenges related to delivery. And finally, what are we monitoring and how are we doing that? Here you see two numbers. Any guesses on what they are? 2,700 and 600. Seconds. Think more. Something related to size. Kilobytes. So 2,700 kilobytes, I did a trick here, so it's 2.7 MB, was the size of our model and our system before compression, and 600 is the one after compression. So which means we were able to compress the size of our machine learning model from this big to almost 75% lesser. And let me tell you how we did that. So we tried a number of things, but the three major things that we did here was quantization, using sparse models, and a TFJF minimization. Quantization, let me take you a little bit into that. You have a neural network. In a neural network, there are a lot of neurons, and there are a lot of layers of these neurons. And these neurons are connected to each other. Now, these connections are represented by weights, and you need to calculate the value of these weights. So what we did as part of this quantization is to reduce the size of the memory that we were using to store those weights, quantization. And now imagine if you are reducing the size of a memory which is representing thousands and hundreds and millions of elements. Okay, millions is a bit too much, but you get the idea. And you reduce the size of each variable, then the overall size reduces by half. Sparse models. What we are doing here is, instead of having the connections between all the neurons in one layer to all the neurons in the other layer, instead of having a dense connection, let's have a sparse model, so that the number of connections that we have there, they are reduced, and that in turn leads to less computation, less amount of data to be stored, and again, less memory. The third thing that we did here was a minimization of TensorFlow.js, the library that is used for all machine learning applications. So what we did here was to identify that which are the functions which we absolutely need and which were there just part of the library. Did some tree shaking and removed them. And we were able to reduce the size of the library that we send out to almost 10 times less of the original size. And this all allowed us to reduce the size of our machine learning models by, as I said, 25%. moving towards speed. Anything that goes in front of the user, you cannot have a slow speed there. Like, I still remember one of the words from my previous CEO who used to say, you cannot waste 300 milliseconds on this one. So exactly here. You cannot waste hundreds of milliseconds on certain computations. You have to be like really fast, an order of magnitude faster at least. And what we did here is, again, three things. Three is the key here. One of them is we did our own custom implementation of the pipeline. Again, looked at what are the functions which are causing the slow speed, remove them, rewrite them, and make it faster. WebGL, the use of WebGL that allows us to use the underlying GPU, that allowed us to also speed up our things. And last but not least, we did a graph limitation. So the page that is used for ad referencing, we take that page. That page at the back end is an HTML. The HTML is converted into a DOM. The DOM is converted into a graph, and that graph is given as an input to the network. Now, that graph can become very deep as the page loads or as the page size increases. But if you let it grow as much as it can, then it will be ultimately an infinite traversal mechanism, and we don't want to have that. So to put a cutoff, we had a cutoff of 200. That worked very well, and without losing any precision, we were able to do the inferencing properly. So these were some tips. Of course, there were many trial and error, and ultimately we were able to identify more. There was the possibility to increase the speed more, reduce the size more, but then we took a cutoff at these points. We were actually thinking that when we are working on a machine learning project, the most difficult aspect would be, as Rupak always says, might be data collection, or even it could be finding the machine learning model for training and training it. But we realized that one of the biggest challenges that we faced were delivery, bringing the model to the users. And here we were facing two issues. One of them is that the whole machine learning pipeline, which language do we use typically to implement everything in a machine learning setup? Python, exactly. But the user, the extension that goes to the user is not in Python, it's in JavaScript. It means that everything that we have done in Python for training and testing and everything, now, for making it user-facing, it has to be converted, the whole pipeline has to be converted into JavaScript. Of course, this was not a surprise, we knew it, but it was also a very time-consuming process. And the second thing is that the team responsible for sending the data out, sending the extension out, that was a different team, which means now we are working with somebody else's release cycles. We are working with a team that has to take care of other priorities as well. And now the solution that we went for was, interestingly, not only a technical solution, rather a combination of technical solution and adjustment of our processes. So on the technical side, we made sure that everything is as independent as possible, as modularized as possible. But then on the processes side, we also made sure that the communication is strong. We made sure that we have a predictable life cycle or release cycle. The priorities are identified upfront, and discussions are happening. So the challenge was fairly resolved by making sure that we have a combination of solutions. Communication is the key. Last but not least, monitoring. The first question that comes here is, when you are talking about metrics, how do you identify which metric you should use to measure the performance of your machine learning model? And here, it's interesting, because the textbook models are very, very interesting, they are very useful, but they are not always the right ones to help you make a decision. We wanted to have metrics, we wanted to have a monitoring in place which can allow us to make decisions. Like, when is the cutoff time when you want to pull out one machine learning model from production and put in the other one? What is that cutoff point? And so we made sure that we have those metrics in place, and along with that, the appropriate signals coming in from the users to make the right decisions. And we have a monitoring team set up that allows us to look at the model and make sure that it's stable, it's reliable before it goes out to the users. Now, after talking about learning, let me switch to the other topic, sustainability. And now you might be wondering, why sustainability and how does all of a sudden sustainability come in here? We were talking about the machine learning models and ad filtering solutions. Because when we talk about sustainability, what comes to our mind is long-haul flights, sports car, and so on and so forth. So let me ask you a question. Here you see two images. The one on the left is my representation, not my, AI's representation of a large language model. And you know by now that large language models are the de facto base of a lot of machine learning applications out there. They are the basis of ChatGPT as well. On the right-hand side, you see an average American car. So what's the similarity between the two? Carbon emissions, that's right, thank you. So the amount of carbon emissions that result in training a large language model is almost the same as 5 times the emissions that an average American car makes in its lifetime. To make things more concrete, training the ChatGPT model, it emitted 78,000 pounds of carbon dioxide. Of course, it makes sense because it's a multi-billion parameter model. But of course, if we cannot just be very casual or irresponsible while using AI, especially when it comes to the impact that it causes on the environment. So we made a conscious decision to keep our models lean and green. So all the discussions that we just had about size, reducing the size, making sure that there is a cutoff point for the number of nodes, making sure that the model has less computations to perform. These were all deliberate, conscious decisions to make sure that we have smaller sizes of the models, and that will allow us to have a sustainable model. So as a rule of thumb, when you have less number of features and you have a sparse model, then you have less computations, which means less computation power is needed, which means less energy is consumed, which means less emissions are produced. So we did this by managing the size. Also, we made sure that the cloud services that we are using, they are carbon net neutral. And the processors that we are using to train our model, they are machine learning optimized. To make things more concrete, our model, in its training phase, we were able to be very economical with the emissions that we produced. And if we compare it to the BERT model, which is one of the most popular large language models out there and forms the basis of very many applications, we were able to do our training with less than 1,000 times that of the industry standards. Of course, the applications are of course different. It's not like a one-on-one comparison, but just to give you a perspective of what can happen. According to NVIDIA, almost 80 to 90% of emissions that happen for a machine learning model, they happen during inferencing. And what we did, we made sure that our inferencing is also fast. Remember all the tweaks that we did about keeping things lean in the beginning? So that actually allowed us to spend very less energy. And compared to an incandescent light bulb, we were spending only 600 times lesser energy compared to a light bulb. So ladies and gentlemen, AI indeed is changing the landscape. AI is changing the way ad filtering works, and not only for the business scenarios out there, not only for the users, but also for the way the engineering is done, the way we build stuff. And at eyeo, we are using AI responsibly and ethically in order to pursue our goal to have an internet which is
fair for everyone.
Thank you very much.
Thank you. We are open to questions.
Thank you very much, the two of you. Yeah, I didn't bring the cube, and I will just make cheeky, quick use of having the microphone myself, because I want to get a question, and before I have a person that goes like, I have a question or 5, I will just ask mine real quick, if I may. So do we have any further numbers on sustainability?
I can take one, yeah, or you go ahead.
Yeah, I mean, we have a whole blog written on this, the whole sustainability aspect. So please feel free to go to our websites and look into those blogs. But do you want to give away the numbers or anything?
No, exactly. So there are many numbers. So if you want to go to the website, you'll be able to see what kind of what kind of processes did we use, what were the exact experiments that we did, and all the comparison of all these numbers are there on the blog. So it's a blog on sustainability on an eyeo website.
Okay, so we'll have to do some reading to do.
Yep.
Yeah, here comes the cube. Aim carefully and woo.
Hello. Hi. Thank you for the presentation. I thought it was really interesting. So now that eyeo is going down this path of real-time ad filtering using AI, I was wondering your thoughts on 5 years from now. Will we only have AI for ad filtering? Will we still need filter rules?
You want to take this from the product side?
Yeah, sure. So 5 years down the lane, ideally we would like to focus on automating the ad detection and filtering. But I believe the filter rules are still going to be there, because at the end of the day, it's the community work. Great minds out there are contributing towards this, and we will still be referring to those as well.
Yeah, I agree. Like AI, right now, as we envision AI, it's like a companion for humans. So it makes our lives easier. It's not there. It's not the aim to like replace everything that we do right now. Rather, how we can support our humans counterparts to do things better and easier.
Is it also because filter rules are utilized to like label your ground truth?
Exactly, you got it right. Okay. So the way machine learning models are made right now, they need to have data, and they need to have those labels, and those labels are coming from those filter rules. And it can be a very nice spiral where you use those filter rules to train a model, and like your work, you generate those filter rules, and then we need somebody to monitor those rules and make sure that they are the right ones. And so we need some kind of human monitoring and human input there.
Hi.
Hello.
Just a quick question. You said that you already shipped the model in the browser extension. Do you mean the main AdBlock Plus extension, or is it some other extension, or what is it? Can I use your model somewhere?
Yes.
How?
It is in the AdBlock Plus extension. So once you download that, you can activate the model.
Okay, thank you so much.
You're welcome.
A follow-up question. I was wondering how this interacts with DNR, as an example. Like how the model can block stuff, like in the page, and where the model is executed. Is on the content side, so content script side,
Yeah.
I would guess, right?
Yeah.
Not the background page.
On the content script side.
Exactly.
So now the DNR rules, and the model is on the content.
That's right. And now that you are mentioning the DNR part, so we also made sure that our model and all the machine learning stuff is now MV3 compatible, so that we can make sure that it is able to be in line with what is coming up next. So now we have our own service worker, and now the model resides over there, and we make sure that it is in...
Thanks. You anticipated my next question.
That's the future.
You need to route it.
Okay, I'm sorry. Just one last question
Who
from me.
has the mic has the question.
Do you have any plans on using this model not in real-time ad blocking, but in all kinds of surrounding tools like issue reports, some maybe assistance to filter maintainers, etc., etc.?
Maybe I can take this question. Yes, we are starting, we started our journey with the MVP, which right now detects ads and does all the inference, everything on the content script end. But we are definitely looking forward to extend this functionality to see if we can utilize this model in different other areas, like it could be dynamic filter rules generations or things like that. But yeah, this is a constant research and with that we do on our end. But yeah, this is on our backlog.
Exactly, and one of the recent researches that we did with TU Munich, that was using generative AI for filter rule generation, and the initial results are actually very promising, and we are like really excited to continue this research as well.
Hi.
Hello.
Thanks. Great talk. I love the extra bits that you always bring. I really enjoy it. I wanted to ask about the model that you're shipping with the extension. Can we like open up a developer console and start asking questions or something? We can. Wow. Okay.
But we still haven't enabled that functionality yet, but we would definitely do that in the future once our model is even more matured and once we have like the right.
So as long as it was in the production,
Yes.
you can.
Okay. I'm making a final call. I saw Natalia also had a question, and we're going to wrap this one up with this question.
Okay, I just wanted to add a bit to your sustainability section, like because I think you know about the fresh water issue. Yes, the training of ChatGPT 3 took 700,000. Yeah, and each 20 questions take about like half a liter of water.
That's true.
Yes. So and here comes my question. So as far as I understand, you used labeled data sets. So was it a supervised learning?
Yes.
Like to me,
It is supervised learning at this point.
And the labels are coming from the filter list, from the
Yes.
manual filter list that we have.
yeah, that's actually you should have mentioned that, because there's a great difference in sustainability between supervised and unsupervised learning.
Exactly.
Yep.
Cool. Glad we were able to clarify this one. Then thank you,
Thank you very
both
much.
of you. This was very interesting.
Okay.